Hey brothers and sisters, my name is Dominic Lucero. I'm the instructor for Boilermakers Local Lodge 549 in Pittsburgh, California. Moving on in our video series about measurements, today we're going to be talking about micrometers. I understand micrometers is definitely not the most common form of measurement pulled for field construction Boilermakers. Myself personally, I've come across it a handful of times out in the field. In my personal life, I use micrometers quite a bit for my hobbies, but it is in our apprenticeship program. And it is important to know. Usually, if you're going to get asked to use a micrometer, we need exact dimensions. So that's something that you want to know how to get and you want to know how to read. If they're looking for exact dimensions and you give them something wrong, it defeats the whole purpose. So the main difficulty I have about teaching people how to read micrometers is that, one, a lot of times they're small. At least the scale is small. So if I put this up here right now, I would not be able to walk you guys through how to pull measurements doing it in this format. So what we have today is I have 3D modeled this micrometer specifically, and I have a 3D animation where I can really zoom in there and get you up close. A couple little things to know about micrometers before we begin. They come in all shapes and functions. The most common form in my experience that we would see out there in the field is going to be what's called an outside diameter micrometer, where its main function is to pull the outside diameter. And micrometers come in ranges. So we have a 0 to 1 inch range micrometer, where this micrometer is going to read from 0 to 1 inch. We have a 1 to 2 inch micrometer, and we have a 2 to 3 inch micrometer. Me personally, that's about as big as I need, at least for working here at the shop. But they do have inside diameter micrometers. They have depth micrometers. A lot of times we're going to be using these for ordering material. Also, our books talk about pulling the inside dimension of a tube after we roll it to check for expansion. You can use an outside diameter for checking the expansion on tubes. I typically use what I call a snap gauge, where it has a little knob right here. You loosen it and it pops right out. It's spring loaded. You can stick that inside the tube, tighten up the knob, and now you can pull your dimension on it fairly accurately. So let's hop over to the computer and we'll have a look.
So what we have here is a 3D modeled version of the micrometer that I had over on the table. This is a 2 to 3 inch micrometer. So all the examples I'm going to be giving you in this video are going to be between the 2 to 3 inch range. Before we get started, I want to go over some proper nomenclature or names of the micrometer. And that way, if I mention any of these names as I go through, you know what I'm talking about. So what we have right here is what's known as the anvil. And between the anvil and the spindle over here, that's where all your dimensions are going to be coming from. So whatever material you have that you're trying to pull dimensions for, it's going to sit in between these two faces right there. Of course, we have the body of the micrometer, or your frame. We have a locking nut. So after you pull the measurements that you need on whatever the material is, you can lock the nut, and that way you don't bump anything and lose that dimension. So over here we have what's known as the sleeve, and as you can see, the sleeve has a scale on it, and we'll go over that in a minute. Here we have the thimble, and the thimble also has a scale on it. Here is my attempt at a knurl on a computer CAD program, and 3D modeling knurls are extremely difficult. The computer can't handle all those faces. And right here we have the ratchet knob. And that's what we're actually going to be using to advance the spindle over to pull the dimension. Micrometers can act as clamps. You can wrench down on this and you never ever want to. You can really damage that. So we use the ratchet knob to pull the dimensions, and that way you make sure that every dimension you pull was used by the same amount of torque advancing the spindle. And that way you get far more precise and accurate measurements. So how do these work? If we come take a look over here on the back side, and we have a look on the inside, you can see that the spindle will go through the body or the frame of the micrometer, and underneath the thimble right here, the spindle is threaded, and there's a little nut in here that receives the threads. But there's something very special about these threads. These threads are 40 threads per inch. And if we take a look, if we do a little bit of math, and we divide 1 divided by 40, we see that we get 0.025. So that's a very important number, and I will show you why. If we look really closely, you can see that we have little marks in between, and every number has 3 marks in between. Each one of these represents 25 thousandths of an inch, and because the thread is 1 thread or 40 threads per inch, that means every revolution on the spindle will advance it 25 thousandths of an inch. So between 0 and the first mark is 25 thousandths of an inch. And then if we gave it one more full revolution, that would put us at 50 thousandths of an inch. And then one more revolution back would give us 75 thousandths of an inch. And then we would have our 0.1 mark. And we're going to go over what all these, how to take these measurements and what these measurements actually mean. Not only do we have numbers on the sleeve and on our main scale, we also have numbers here. And essentially how this works is, this is our range. So we know that this is a 2 to 3 inch micrometer. So it would be 2 point, and this would be our second number. So if we were past the 1 mark, we know it would be 2.1 something. And if we're looking at this right here, we see that it is just past the 7 mark. So that would be 2.7 something. And that something would be read from right here. We see that the 13-inch line is just past the 7 mark, which means that would be 2.713, or 713 thousandths of an inch. We also have a vernier scale back here on the end, and we'll go over this as well in some examples, but essentially the way that works is when it's not exactly on one number, then we're going to be able to pull 10 thousandths of an inch. So say it was halfway in between 12 and 13, kind of like how it looks right here, almost at 13 but not quite. If we were pulling 10 thousandths of an inch, we would come here on the back and look, and we can see that this line right here lines up exactly with 4. So that measurement would be 2.712, 4 10 thousandths of an inch. So let's go ahead and see this thing in action. So what I have here is a 3D animation of the micrometer. That way we can see it in action, and we can move all the way through how we're actually going to pull dimensions in a way that we can all see very clearly. So first things first, let's assemble the micrometer. So if we take a look here, we can see that we are at the very end of our scale, and this line running all the way down the sleeve indicates where our measurement is. And you can see that we're at 0. We are at 0 at the end of the scale. So that dimension there would be exactly 3 inches. Let's go ahead and run this all the way down. As it runs down, you can see the spindle advancing in as we screw it in, and that's how we would be pulling our dimensions. Once again, we're at the 0 mark at the very beginning of the scale, and we're at the 0 mark on the thimble, which means we are exactly at 2 inches. So that's from one range of the scale to the other range. Now if we back this off 1 revolution, you can see the numbers on the thimble. The numbers on the thimble range from 0, and they count up 1, 2, 3, 4, all the way up to 24 and then back to 0, which would be a full 25 thousandths of an inch. So this dimension right here would be stated as 2.0, and we're at our first mark, 2.5, or 2 inch and 25 thousandths. Advance it back one more revolution and one full revolution. We now have 2 marks here. If we know that this distance between our 0 and our first mark is 25 thousandths, and now we're at our second mark, that now puts us 25 thousandths or 50 thousandths of an inch. So that would be expressed as 2.050, or 2 inch and 50 thousandths. Now for an actual measurement, if we back this off and we landed on the 12 mark, we now know we are 12 thousandths of an inch past the 50 thousandths mark. So it's fairly simple. We would just add 12 thousandths of an inch to 50 thousandths, and that will give us our measurement. So 50 plus 12 will give us 2.062, which would be 2 and a 16th of an inch in between the anvil and the spindle. Let's try another one. Now we gave it about 1.5 revolutions, and now we have landed at our next mark, which is indicated by a 1, which means we are now at 2.1 inches, or 2 and 100 thousandths of an inch. Take it back one more full revolution, and we are now at 2.1 and the first mark, which represents 25 thousandths right here. So 2.125, and that is also known as 2 and 1/8 of an inch in between your anvil and your spindle. Let's try another. If we back it off significantly, and we land at the 13. So a very cool feature, like I had told you guys before. If you look, we are not quite at the 13. We're just a little bit shy of it. So if we need to know what that measurement was, we could flip to the backside and check out the vernier scale. Okay, and if we look at all these lines on here, we're looking for the line that matches up best with the lines on the thimble. And as we can see, the 4 is not quite there, the 3 is not quite there, and then we look, we're past on the 6, we're past on the 7. So this mark right here lines up best with this line, which tells us that it's 5/10 of an inch. So if we come back and look, we know that we are just past the 75 thousandths mark. So now we have to add 13 to 75 thousandths, which would give us 8.7. And then on the back side, we're on the 5, which would give us 1.875. And 2.1875 is also known as 2 and 3/16. Let's try another. Now we're past the 200 thousandths mark. And if we look here, we're at the 50 thousandths. So this measurement would be 2.250, or 2 inch 250 thousandths, also known as 2 and 1/4 inch. We'll go ahead and spin this all the way back. And now we can see we've landed at the 5 mark. So now we know we're at 2.50 or 2 and 500 thousandths, also known as 2 and 1/2 inches. So if that's the measurement you needed, you would lock in your lock and you would have your dimension. And that's how to use a micrometer.
One last thing before we get going. Hands down, the number one difficulty most people seem to have when using a micrometer is how to hold it. And it's very simple. If you take your index finger and your pinky finger and you balance it on there and you hold your thumb, you can hold this very comfortably. And then whenever you take whatever it is that you're trying to pull a dimension on, you can hold it in there. And you can set it in between the anvil and your spindle. And advance the spindle in with the ratchet stop. And now I can get my measurement. So thank you so much for taking time out of your day to advance your skills and understandings with how to read micrometers. I know it's not something that we do every day, but when we do use a micrometer, it's because the dimensions that we're trying to get are extremely critical. So in keeping with being a skilled and trained workforce, it speaks to our professionalism, it speaks to our craftsmanship. If you don't understand it now, it's okay, come down. I'm happy to sit down and work with you on how to read measurements with a micrometer, and I hope you get the education you deserve.